All right, guys. So we move to the next question, which is question number 3, right? Yes. So the next question, question number 3. Okay. The state of matter with definite volume, no definite shape. Option A, we have solid. Option B, we have liquid. Option C, we have gas. Option D, we have all of the above. Now, you agree that in the first question or the first two questions, I did give some basic difference between solid, liquid, and gas, and I said that solid has a definite shape and a definite volume, right? Yes, I did say that liquid has a definite volume. For example, 1 liter of liquid is the volume of that liquid, but liquid does not have a definite shape. Now, liquid um, carries the shape of its container. So the shape of the liquid is actually the shape of its container. If you place 1 liter liquid into a container that is spherical, what happens? The liquid takes the shape of that container. Now, if you place that same 1 liter into a rectangular container, the liquid takes the shape of that container. So you can see we are moving 1 liter. The 1 liter is not actually changing, it's 1 liter, but different shapes of container. So that volume is constant. That means it has a fixed or a definite rather volume, but it does not have a definite shape. So the answer is not gas. The answer is not solid. The answer is not all of the above. Gas does not have a definite shape. It does not have a definite volume. Like I said before, any volume accessible or available to the particles of the gas is actually the volume of the gas. I repeat, any space available to the particles of the gas is regarded as the what? The volume of the gas. Definite shape, definite volume. Definite volume, no definite shape. No definite volume, no definite shape. So the answer to this question is option B. So quickly, we move to the next question, which is question number 4. Now for question number 4, we have application of pressure. Application of pressure on ice will dash melting point. Option A, increase. Option B, decrease. Option C, increase then decrease. Option D, decrease then increase. Now, I want you to pause this video, write out the question, try to answer them yourself and see if you're correct. Then you play back to see my answer and check if you are correct. Now, in a regular class setting, you all know that all of you in that class will shout crease. Nobody will say increase or decrease. All of you shout crease. Now, in this case, I hope you are not doing that. So, one thing you should know is that, does pressure affect melting point of solid? That's what you should be thinking first. Does pressure affect melting point of solid? Yes. Application of pressure either increase the melting point of solid or decrease the melting point of solid, depending on the nature of the solid. So depending on the nature of the solid, we have two types of solid due to application of pressure. We have solids that expand on melting, and we have solids that contract on melting. Now you are going to put this point down. Put down this point. There are solids that expand on melting, and there are solids that contract on melting. So, right, for solids that contract on melting, or solid that contracts on melting, increase in pressure, decrease melting point. So for solid that contracts on melting, increase in pressure, do what? Decrease melting point. An example of this is ice, brass. What again? Another example should be, I'm trying to add one to it. Another example should be cast iron. Yes, cast iron. So this solid on melting, they what? They contract. Application of pressure will decrease their melting point. However, the next point you should know, for solids that contract, sorry, we don't contract, that expand on melting, increase in pressure, that means application of pressure, what? Increases melting point. So I'm going to give you examples of such solids that expand on melting. E.g., think we have copper. Yes, copper is one of them. What again? Gold. Gold is one of them. What again? Paraffin wax. Paraffin wax. So application of pressure on all these guys, copper, gold, paraffin wax, will increase the melting point. Application of pressure on all these solid, ice, brass, cast iron, will decrease their melting point. I'm going to show you an application on this on ice. Now, there's what we call regulation. Now, regulation is actually using a string to pass through ice. Now, once we have a cube of ice, if this is a cube of ice, and I stretch out a string with high pressure on the ice, it will what? It will melt that part of ice. So the string will pass through the ice block and comes out from the other side. Once it comes out from the other side, the ice freeze back. So what just happened? I just apply pressure on ice and it melts the what? And it decrease the melting point. It melts that ice from that point, and we can cut through ice due to what? Application of what? Of the pressure. Now, another application of this is you've seen people skating on snow. Now, those people skating on snow, now once they stand on the skateboard, pressure from that person will be applied on snow, and snow will melt to what? To water, and that water will serve as lubricant for that what's it called, skate to slide over. So we're going to answer this question now. So how do we answer this question? Application of pressure on ice will dash melting point. The answer is not decrease. The answer is not increase then decrease. The answer is not decrease then increase. Sorry. The answer is not increase, rather. The answer is not C. The answer is not D. Rather, the answer is option B, because ice falls under this category of solids that contract on melting. So increase in pressure will decrease melting point. So that's that. We move to the next question, question number 5. So I hope you are writing this. Pause this so you can write it well, so that we don't waste time here. So I'm cleaning now. Number 5. Number 5. Which of the following is incorrect? Option A, evaporation occurs at any temperature. Option B, evaporation takes place within the liquid. Option C, temperature may change during evaporation. Option D, no bubbles are formed during evaporation. Good. Now, write the question, try to answer the question, play back and see if you are correct. Now, if liquid turns to gas, the term used is called vaporization, not evaporation. Conversion of liquid to gas is not evaporation. The term used is vaporization. But vaporization can occur in two ways. Vaporization can occur in two ways, either by evaporation or boiling. Now you see these two, we convert liquid to gas. Conversion of liquid to gas is vaporization. However, vaporization can occur in two ways. So we're going to look at the differences between evaporation and boiling, so we can easily answer that question, right? Good. So we'll look at the differences between evaporation and boiling. Number one difference occurs at all temperature. But this occurs at a given temperature called boiling point. So I'll try to explain here. As it stands now, evaporation is occurring around you. Any liquid around you is evaporating because evaporation occurs at any temperature. The liquid inside your room temperature, is what? Is evaporating at that temperature. The liquid outside your house is evaporating at that temperature. Liquids evaporate at all temperature, but liquid boils at a particular temperature. So the temperature at which liquid boils is called what? It's called boiling point. Now, the next point we should look at now, or the next difference, is that evaporation occurs at the surface of the liquid. However, boiling occurs throughout, or some may say within, the liquid. Now, I'm going to explain this. Watch. If I have a container, a vessel containing water, and this vessel containing water has different particles, right? Yes, have the water particles, a lot of particles, not different, same particles of water, but they are much. Okay, let's say it has 1, 2, 3, 4, 5, 6, 7, right? Yes, and I want to put them here so it will be clearer. 1, 2, 3, 4, 5, 6, 7. Now let's each of them has their specific kinetic energy. So you remember that for liquid has a higher kinetic energy than solid, so the particles allow them to move a bit. So they have their separate kinetic energy. Let's say this guy's kinetic energy is 7 joules. This one is, let's say, 10 joules. This is 5 joules. This is 2 joules. This is 4 joules. This is 0.5 joules. This is, let's say, 1 joules. Now, for any of these particles to escape that liquid and turn to gas, they must possess certain kinetic energy. That kinetic energy will make them move upward to the surface of the liquid. Now, if they possess extra kinetic energy, they will escape the surface of the liquid. Let's assume that to move away from this liquid, to escape the surface of this liquid, you must have a minimum of 5 joules. So that means 1, 2, and 3 will move to the surface of the liquid. 1, 2, and 3. They will move to the surface of the liquid. Now, if they have extra energy, they will overcome the surface of the liquid and jump out as gas. So what does it mean? It means that for evaporation to occur, those energetic particles will move to the surface of the liquid. It is from the surface of the liquid that is where evaporation occurs. Now, the next difference is leads temperature rather decreases. Temperature what? Decreases. At this point, temperature increases and get to a point where it becomes what? Constant. At that point it becomes constant. That's where it boils, right? Yes. So before boiling and at boiling, there's a temperature difference, right? The temperature what? Increases. Now, what does it mean? Now, evaporation leads to decrease in temperature. Remember, I will explain. Now, these are the energy of the particles, right? And the sum of the energy of these particles equates the temperature. The sum of everything here, I will equate it to what? The temperature. Remember that it is only the energetic particles that will leave at evaporation. So if this goes, this vaporize, we are left with what? Little, or we are left with particles with less energetic particle. So since the highly energetic particle has escaped, leaving the less energetic particle, what happens to the temperature? The temperature will decrease because the amount of energy, of the resulting energy left, has decreased. Now, since the amount of the resulting energy left has decreased, the temperature of the liquid what? Decrease. A perfect example, a practical example I'll give to you. Now, if you pour methylated spirit on your skin, after some time, the methylated spirit what? Vaporize. Abi? Yes. But if you check at the point of evaporation or after evaporation, you feel what we call a cooling sensation. Pour methylated spirit on your skin. When it evaporates, you will feel a cooling what? You will feel a cooling sensation. What happens is that the particles of the liquid methylated spirit extract energy from your body to become energetic. They extract heat from your body to become energetic. Then what? Vaporize. Now, if you extract heat from a substance, what happens? It leads to cooling of the substance. If you apply heat to a substance, what happens? It causes what? The body becomes hot. Extract heat from a substance, the body becomes what? Cold. So that is it. So temperature decreases at what? During evaporation, but that is temperature what? Increase and got to a certain point during boiling. So the next difference between evaporation and boiling is that bubbles are not formed during evaporation. However, bubbles are formed during boiling. So in this concept now, can we actually answer that question? Yes. Which of the following is incorrect? Evaporation occurs at any temperature. Yes, evaporation occurs at any temperature. Evaporation takes place within the liquid. That is not true. Evaporation occurs at the surface of the liquid, right? Yes. Now, temperature may change during evaporation. Yes. But however, temperature change is decrease in temperature, not increase in temperature, because the temperature of the resulting what? Liquid after evaporation decreases. So evaporation leads to cooling. Now, the next one, no bubbles are formed during evaporation. That's true. So the answer is not A. The answer is not C. The answer is not D. However, the answer here is option B. Option B. So if you're writing those stuff down, write it down quickly before I clean, or you pause it because I'm about to clean the board. All right. So next question is question number 6. Question number 6. Okay. Which of the following factors does not affect rate of evaporation? Option A, temperature. Option B, humidity. Option C, surface area. Option D, depth of liquid. So pause the question so you write, answer, then and play back to see if you're correct. So we are going to look at, we are still around, what's it called? Evaporation, rate of evaporation. There are several factors that affect evaporation. There are other factors that affect how fast or how slow evaporation can be. Now, one of the factors, we are going to look at factors affecting the evaporation. Factors affecting evaporation. We are going to look at a bit of them. 1, 2, 3, 4. One factor that affects evaporation is temperature. Like I said, temperature, evaporation occurs at all temperature, right? Yes, evaporation occurs at all temperature. However, the rate of evaporation is affected by temperature. Increase in temperature will increase the rate of evaporation. Now, the rate at which evaporation will occur at a higher temperature is higher than the rate at which evaporation will occur at a low temperature. One of the applications of evaporation is drying of wet clothes. Yes. Now, on a sunny day, if my wet cloth or your wet cloth is outside a sunny day, and the same amount of cloth or the same cloth or another wet cloth rather is inside your room, where will it get dried faster? Where? The answer should be outside, because outside we have higher temperature than inside the house, right? Yes. So what it means is that will both of them dry? Yes, but the time at which the cloth will get dry differs. It will be higher, it will be faster outside than what? Inside. So though evaporation occurs at all temperature, however, the rate of evaporation is affected by temperature. The higher the temperature, the higher the rate of what? Evaporation. Another factor that affects evaporation is wind. Wind. Now, wind has a way of increasing the rate of evaporation. Now, you can wake up at night, right? Yes, wash your uniform, blow it with wings, with like this. What you're trying to do is that you're trying to like apply wind to increase the rate of evaporation, so your uniform becomes dried before the morning. Or you take it to a large fan, a huge fan, blowing the what? The cloth. What are you trying to do? You're trying to apply wind, the application of wind on the rate of evaporation. And the next one we are going to look at is humidity. Right? Yes, humidity is actually a measure of the amount of water vapor in the atmosphere. Now, during raining season, we say it is high humidity. because we have large amount of water vapor in the atmosphere. Now, during dry season, we say low humidity because we have less amount of water vapor in the atmosphere. Now, you will agree with me now that your wet clothes will dry faster in dry season than in rainy season. So are you seeing it out? So increase in humidity decreases evaporation. Increase humidity means wet air. Decrease humidity means dry air. Increase humidity means there's a large amount I repeat, increase humidity means there's a large amount of water vapor in the atmosphere. Decrease humidity means there's low amount of water vapor in the atmosphere. So humidity what affect rate of evaporation. Increase in humidity, decrease the rate of evaporation. Another factor that affects is surface area. I'm going to explain this. Now, surface area. Surface area is actually the area occupied by the liquid. If I have a cup of water here, now at any temperature, this water is evaporating. But however, I may not see the difference in water level. This water is decreasing. The water in the cup inside your room is evaporating. But you will not see the sharp change in the amount of the water or the volume of the water. Why? Because the rate of evaporation is so low, it's so small. But in days, in weeks, in months, everything will dry up due to evaporation. Now, however, can I make this thing to evaporate faster? Yes. What I will do is to increase the surface area of the water. How may I do this? I may carry this water and pour it on the ground. If I pour it on the ground, spread the water over a large surface area on the floor. Go outside and come back. It will dry. You usually apply this thing at home. You have water on the ground. You get what's it called, broom. You spread it all over. You increase the surface area. When you go and come back, within a short period of time, it has what evaporated and everywhere is dried. So in this concept now, we can actually answer this question, right? Yes, the rate. Which of the following factor does not affect the rate of evaporation? Temperature affects, yes. Humidity affects, yes. Surface area affects, yes. Depth of the liquid does not affect. So the answer is option